So the energies of electron in an atom are quantized. That means the energy of an electron is in the small packets called h nu. Okay. The second point is the electron is revolving around the nucleus in a certain circular path of a fixed energy called stationary orbit. What is stationary orbit? எலக்ட்ரான் வந்து ஒரு ஃபிக்ஸ்டு பாத்தில் சுற்றிக்கிட்டே வருது. அந்த ஃபிக்ஸ்டு பாத்தை என்ன சொல்கிறோம்? Stationary orbit. Okay. Next, third one is electron can revolve only in those orbits in which the angular momentum of the electron must be equal to integral multiple of h by 2 pi. That is angular momentum and mass velocity into radius. So mvr is equal to nh by 2 pi. Here n is equal to 1, 2, 3, etc. The next postulate of Bohr is as long as an electron revolves in the fixed stationary orbit, it does not lose its energy. However, when an electron jumps from higher energy state to lower energy state, the excess energy is emitted as radiation. The frequency of emitted radiation is E2 minus E1 is equal to h nu. From this expression, Bohr calculated the nu, that is the frequency of radiation, nu is equal to E2 minus E1 by h. So applying Bohr's postulates to the hydrogen-like atoms, that is the atoms having only one electron such as hydrogen, helium plus ion, lithium 2 plus ion. These are the hydrogen-like atoms having one electron. Okay, so for this type of electron, atoms with one electron, he find out the radius of the orbital. Okay, the radius of the orbital and also the energy of the electron revolving in the nth orbital is also calculated. So the radius Rn is equal to 0.529 n square by z angstrom is the radius of the atoms having single electron like hydrogen, helium plus ion and lithium plus ion. Next, the energy of the electron is also calculated, or the energy of orbit is calculated. The energy of this first orbital is En is equal to minus 13.6 z square by n square electron volt per atom, or En is equal to minus 1312.8 z square by n square kilojoules per mole. Next, let us study the limitations of Bohr's atom model. Okay, Bohr's atom model is applicable only to the species having one electron like hydrogen, lithium 2 plus ion, He plus ion. Okay, it is not applicable for the electrons having more than one atoms. Okay, atoms having more than one electron. Okay. The second drawback of Bohr's atomic model was it was unable to explain the splitting of spectral lines. Okay, it was unable to explain the splitting of spectral lines in the presence of magnetic field, that is Zeeman effect. What is Zeeman effect? That is the splitting of the spectral lines in the presence of magnetic field is called as what? Zeeman effect. Splitting of the spectral lines in the presence of magnetic field is called a Zeeman effect, and the splitting of spectral lines in the presence of electric field, or that is called a Stark effect. Okay, first Bohr's atomic theory வந்து சிங்கிள் எலக்ட்ரான் சிஸ்டத்தோட ஆர்பிட்டோட எனர்ஜியோ அல்லது எலக்ட்ரான் சிஸ்டத்துக்கோட ரேடியஸையோ கண்டுபிடிக்க உதவுது. செகண்ட் வந்து அந்த ஸ்பெக்ட்ரல் லைன்ஸு மேக்னெட்டிக் ஃபீல்டுலேயும் எலக்ட்ரிக் ஃபீல்ட்லேயும் ஸ்ப்ளிட் ஆகுது. அதை வந்து எக்ஸ்பிளைன் பண்ண போரால் முடியலை. தேர்ட் ஒன் இஸ் Bohr's theory was unable to explain why the electron is restricted to revolve around the nucleus in a fixed orbital. எதனால ஒரு எலக்ட்ரான் வந்து ஒரு ஃபிக்ஸ்டு ஆர்பிட்டலில் சுற்றுது, ஏன் அடுத்த ஆர்பிட்டலில் சுற்றக்கூடாது அப்படிங்கிறதையும் போரால் என்ன செய்ய முடியல, எக்ஸ்பிளைன் பண்ண முடியல. தீஸ் ஆர் த 3 drawbacks ஆஃப் போர்ஸ் அட்டாமிக் தியரி.